Hi there. So today we're going to be using everything that we've done with our rules of exponents, and we're going to be working on slightly more complicated problems. So we're going to be multiplying and dividing monomials. Monomials are one-term expressions, as we'll see in the vocabulary. Okay, so a monomial, and you're going to be writing this down, record all of this in your notes. So a monomial is a one-termed expression. So an example, or a couple of examples of monomials are these. Go ahead and write them down. Monomials can be any number or combination of numbers using multiplication, numbers and variables. So a monomial is one term. Terms are separated by addition and subtraction. Now a constant, if you recall, is just a number. No variables at all. So examples there would be any number you can think of. They can be decimals, they can be fractions. They just can't have variables. Then a coefficient is the constant number that's being multiplied times a variable. So if you look up here in our examples, here 2 is the coefficient in front of x. 4 is a constant. For each of these separately is a monomial. Over here, -1, the unwritten number, is the coefficient. And we've used that term quite a bit as well. So it's the multiplier. Again, pause the video if you need more time. So as I said, we're going to be multiplying and dividing monomials. When we multiply monomials, we are going to multiply each part separately. So you can rearrange if you need to. We're going to multiply coefficients times coefficients. We're going to multiply x's times x's, y's times y's, and so on, using your rules of exponents. When we get into division, we'll do the same thing. We'll rearrange, we'll divide coefficients by coefficients, and each variable by themselves. Again, use your rules of exponents. Okay, so now we're going to get into the examples on the next page. So go ahead and write down this next example. Pause the video if needed. The first thing that we're going to do is we're going to rearrange them so that we can multiply our coefficients times coefficients. So if you need to, go ahead and write it out. We can write this as 2 times -2 for these. And then we're going to multiply our x's together. And I like to write them just to be sure. As you get more comfortable, you'll have to write less and less. And then last, we still have a y in here. Now remember, multiplication, just like addition, commutes. What that means is you can do them in any order, and it doesn't change the answer. Okay, so now that we have them all written out, let's go ahead and simplify each part separately. So multiplying 2 times -2 gives us -4. If you multiply x to the -1 times x to the 4, remember we still follow our rules of exponents. So this is going to be x to the -1 plus 4. We have the same base. We're going to keep the base and add the powers. We couldn't combine it with our y because that's separate. So knowing that our y is to a negative power, I'm going to go ahead and put that in the bottom of my expression now. And I'm going to change it to positive. Okay, so it's part of a numerator now. If you want to, as a reminder, do that. Then we can move it to the other location, make it positive. Now we're ready to simplify the entire thing. Notice the -4 has to stay there. That's not a power. That's just a number. It's a coefficient, so that doesn't move. So then when we rewrite the whole thing, for this part, we're going to have x to the -1 plus 4, so x cubed. So I'm going to rewrite everything as -4 times x to the 3rd power all over y. Then I'll box that answer. Okay, if you need to go back to anything, if it went too quickly, go ahead and rewind and rewatch the video. Okay, now that we have practiced with our multiplication steps, let's go ahead and try a division example. We're going to do this in very much the same way. So we're going to start by just dividing the coefficients. Okay, so I like to also start with a big fraction bar. Now if I divide 2 divided by 2, I get 1. And I don't really have to write it. I'm going to write it for now as a placeholder. But when I do the division, unless the top is smaller than the bottom, it's just going to go on the bottom. So here they're the same, so the 1 goes on top. Next, we can divide our x's, and we'll use our division rule for exponents. We have the same base, so we're going to keep that base and subtract the powers top minus bottom. And that goes on top as well. So x to the 4 minus 2. Last, we're going to divide our y's. Same thing, it goes on top. Y to the 2 minus 4. Okay, so far there's nothing in our denominator, so we can stick this over 1, or we could have just not written the fraction. And I'll show you a shortcut later when we have a bigger denominator than the numerator, bigger power in the denominator, of what we can do. So for now, we're going to start here. So the 1 we don't really even have to write. Okay, so our x's can simplify into 4 minus 2, so x squared. Then your y's, 2 minus 4, will be y to the negative 2. Now, we always have to leave our answers with only positives. And so what we're going to do is remember that this is still over 1. We can move our negative exponent expression into the other location and make it positive for our final answer. So we're going to write this as x squared over y squared. We move it and turn it positive. Now, like I said, there's a shortcut to this. So I'm going to try this problem again. Some of it I don't have to go through quite as slowly though. Okay, same problem. Now I'm dividing my 2's. I know that that's going to be a 1. I'm still going to start with a fraction. Okay, so my 2 divided by 2, 1. You can write that or not, depending on your comfort level. We'll get rid of it later. Now I'm going to divide my x's, and I've got power expressions where the numerator's power is bigger than the denominator's. So I'm going to do that on top just like before. But with the y's, because the bottom power is bigger than the top power, if I do that subtraction and I subtract the bigger minus the smaller, I can do that as long as it stays in the same place where it started. So the bigger number's on the bottom. If I just write it on the bottom, then I can do big minus small. That's the shortcut. So then you're not doing this step and then moving it. It's already there. But if you try this and you start getting them wrong, go back to the original, just do top minus bottom every time and then move it. And that's perfectly fine. You'll get the same correct final answer in the end. So from here, we should still get x squared over y squared when we do the subtraction, just like before. So these are the same answer.